Hello everyone, this section is 6.1. It's about antiderivatives and the rules of integration. So what you will see is the work we've done. We're going to reverse it to something called the antiderivative, and this is the beginning of, of this chapter. So what are the antiderivatives? If you have a function f, it is an antiderivative of f, of some small f, on an interval I, if f of prime, f prime means its derivative equal to f of x. And this will be clear with the examples for all x in I. So let's look at this. So if we have this cap f is x squared, it's an antiderivative of 2x. Why? Because the derivative of 2x of x squared is 2x. So that's it. Um, so we're going to do a reverse of what we've done before in differentiation, right? So before, if you have x squared, you differentiate and you find 2x. Now, when you do the derivative, you're going to find x squared. The only thing is there are two ways of course there are different rules, but there is two ways of understanding here. If we're looking for a general antiderivative, then it has to be some x squared plus c, and I'll explain where c is a constant. If it is definite, if it's specific, then it's going to be x squared. So let's talk a little more, then get to realize this. But the good news about this is you've seen differentiation, so you're just going to be reversing it. So if we have an capital F here as x cubed plus 2x plus 1, it's an antiderivative of 3x squared plus 2. Why? Because if you differentiate this, you're going to get this. So here is a theorem 1 for this cap or C, a constant. Why? We're going to add this constant, and I'm going to explain it when we're looking for antiderivative in general. So let's take the example of x squared. Is an antiderivative of the 2x. Why? If you take g prime, you're going to find 2x. So g of x is x squared. If you do g prime of x, you're going to find 2x, right? But as I mentioned, to reverse it, there are many functions that will give 2x. Let's explain it this way. If I have another function, let's call it h of x squared plus 2. What is the derivative of this one? It's also going to be a 2x because the derivative of 2 is 0. If you take another function, x squared minus 5, what is the derivative of m of x? It's also going to be 2x. So because there are many forms of this, this is what we're going to represent with that number c, that is a constant. So this x squared plus c means c can be a 2, it can be -5, it can be any constant number. So this is a family of functions, a family of functions that have derivative 2x. So this is very important to keep in mind. When you're looking for the antiderivative and it's general, you will need to add c because you're not sure which one you will be pick it, or you're just going to say in general this is what it is. And here is an explanation for it for the graph. So you see these are different functions, and their derivative is the same, because if you take the slope here, the tangent, they are all the same way, they all behaving the same way, they all parallel, you see. So the derivative are going to be the same all the time, which is that 2x. So keep that in mind. F prime of x is a 2x. So when you're reversing it, you will need to have the c constant first. So that takes us to this relationship to define the indefinite integral. What is an indefinite integral? And this is with Leibniz came up with this symbol. It's like an S. Think about S stretched. Uh, why the S? Because the integral stands for a summation, for a sum. That's why he used this symbol, which like stretching an S there, because the integral is going to be a sum of some parts, and we'll get to that a little more. So the integral of this function f of x, this indicates to what variable. It's going to be this antiderivative plus c. Why? Because if you differentiate f prime, you're going to find f of x. Right. So the function to be integrated is called the integrand, and the constant c is called the constant of integration. The expression dx following this integrand is f of x. Remind us of that operation in which is performed with. It's like a differential, but here it really reminds us to what variable we're working with. If the independent variable is t, then we're going to write f of t dt, right? In this sense, both t and x are dummy variables, all right? So we'll see a little more this with these examples. So we saw with the differentiation many rules, and now with the same thing for integration, there are rules that will help to go back to these functions, that if you differentiate them, you find these integrals. So the rule one, the indefinite integral of a constant is kx. Why? Of course, so example, and the examples here you're going to see are similar to the homework. They're straightforward following these. So a 5 dx is just going to be 5x. Remember why? Because if you differentiate 5x, you need to get a 5 plus c. C can be any number, constant, because if you differentiate that constant, it's going to be 0. So we say that the 5x is the antiderivative here. And similarly, so you see for a 2, the answer is 2x, because if you differentiate this, you get a 2. So the answer is 2x plus c. Pi is also a number, so pi x squared plus c. So rule number 2. For the power rule, how do we reverse a power rule? So if I have x to like the 5th, right? You do plus 1 and you divide by it. And of course, we'll add the c here. So x to the 6th divided by 6 plus c, which means if I differentiate this x to the 6th divided by 6, what will happen is 6 divided by 6 will be 1, and that's going to leave me with x to the 5th. And here you have few examples to follow. So maybe you can pause the video and do these examples, or if you have, let's do number C, because C is interesting, like what we've done before. If we have a this rational exponent, we make it a negative exponent. You see, like how you used to make positive exponents negative exponents positive. Here you're making a positive exponent negative because you need to carry uh, this power rule for which is R2, this second rule. All right, so I think now you're familiar with this, because when you take this negative 3 halves and you add 1 to it, you should get 3 halves plus 2 over 2, which is negative 1 half. So this becomes negative 1 half, and you divide by it, and that's, if you divide by a fraction, it means negative 2, and that gives you this answer. So that's the answer for C. Rule number 3, if we have a multiple, just like we did for differentiation, it's not going to be used. It's going to stay to the side until you find these antiderivatives. So a 2 here, it comes to the outside, and you work this with the power rule, and you find the answer. And if you decide to, just keep in mind here, if you decide to distribute back the 2, it's going to be 2 over 4 t4 plus let's say 2k or whatever constant, right? And let's just look at it here. It's going to be t to the 4th by 2 to simplify, but the constant is just a constant. This 2k or 3k or whatever is just k constant or c constant or c. So whatever it is, it's still a constant. So you don't know yet what that constant is, so you just call it a constant. That's the important part of this, and that's how it's explained in this next one. You see 2k or whatever is just a constant. So at the end, what we want is something, if we differentiate, you're going to find 1 half and a 4 and a t cubed and a 0, right? Okay, so we'll erase this, and so this is still a constant, some constant, and we'll replace it with C, whatever it is, right here. And similarly, again, we have a multiple, it comes outside, we do the power rule on that, and it doesn't matter what numbers you have, you're going to replace them with the C. And the check is you differentiate this to get this integral. So the rule number 4, similar to differentiation, you do this with integration as well. If you have the sum, you can split, or the difference you can split, just like we did with derivatives. We can find the derivative of different parts. Now we can find the antiderivatives for different parts. So if I have this example, instead of attempting to find for the whole thing, you're going to split it, because you have a addition and subtraction. Those are, so this is rule number 4, and use the rule number 3 to put these multiples outside. Then use rule number 2, which is the power 1 on all these, and you leave the C at the end, right? So now this is going to be intuitive. So the R5, or the 5th rule for this indefinite integral, is the Antiderivative of Ex is the X, because we saw in the end of the other chapter um, that the derivative of Ex is Ex, right? So the derivative of Ex with respect to X is just Ex. So similar thing here, right? So again, if I have different parts, I can use the other rule to split them, um, each integral by itself. We take the 2 out. The derivative of Ex is just Ex. This one, the power rule applies, and the C at the end. Okay. Rule number 6. For the or R6, if you have, we saw the derivative for the natural log to be 1 over x. So we did the derivative for natural log, and we find to be 1 over x. So now a similar thing, we want the antiderivative. So if we have x to negative 1 or 1 over x, uh, it's going to be the natural log with the absolute value to x plus c. All right, and you have some, so probably pause the video, follow these, they're not a problem now. Kind of just they're pretty clear. So let's just give you some ideas. What is a differential equation? You have, let's say, this f prime of x equal to x minus 1, and we wish to find f of x. So what is f of x in this case? You see this f prime of x is put inside here the integrand, which is the f of x. So same thing. So now you should recognize that if the function inside here is f prime, so maybe let's write it this way. If this is f prime of x, then the answer, which is this one, it should be f of x. Of course, why? Because when you differentiate f of x, you get f prime of x. That's how we define this, right? If you have a function inside, which is the integrand, and you find the antiderivative. What's the antiderivative? It's a function. If you differentiate it, you find this. So same thing here. If you have f prime inside, that means you're just finding f of x. So there are different ways. One way we say that this um, f of x plus c, that's one way. Or if this is f prime of x, um, it doesn't matter. What I want to get to is it doesn't matter what you do, as long as when you differentiate this function, you're going to get the integrand inside. Okay, so what is a differential equation? Is a function or equation that involves the derivative. So that's what's going to be explained in this slide. And as you see, of course, we'll need to find for 2x, right, for 2x minus 1, so the antiderivative is going to be x squared minus x plus c, and depending on what c is, we're going to have a different function. And the graphs of some of these functions having and observe that the slopes of the tangent lines are the same as I described before. So these graphs have one property in common. For any fixed value of x, the tangent lines of these graphs have the same slope. This follows because any member of the family of these functions, x squared minus x plus c, must have the same slope, 2x minus 1. So, there are many, but many occasions you're going to find particular ones or that apply to certain problems. And let's, for example, here, if we know a point, then we will use that point to find the constant c. And for example, but more generally, we're going to use something called the initial condition, right? And let's look at the initial value problems and explain some of that. An initial value problem is one which we are required to find the function satisfying one, a differential equation, and two, one or more initial conditions. All right. So it is an example. F prime is this function. F of 1 equal 9. We are required to solve this. This is almost like a system because you're solving to find f of x. However, this f of x such that f of 1 equal 9. So we do the antiderivative. We find the general formula for the antiderivative. Then we use f of 1 equal 9, which means substitute 1 for x, and equal to 9, which means will give us a c. So we get 7 plus c equal to 9. 7 plus c equal to 9. And we'll do another example of this. So c is 2. So therefore, the required function of f is given by this. So you see, no longer c is there because now it's more specific. It's a particular problem. C is equal to 2, and that's it. So let's look at some examples. Um, find these indefinite integral. We're going to put a 2 outside. Um, here dt, so the variable of integration here is a t, so it doesn't have to be x, whatever the variable that is used. And so we add 1 and we divide by that, and that's going to give us -5, and we divide by it. So it looks like we have 2 this plus c. There are a few ways to write it, or um, c minus, because you may see it in the system this way, so let's write it also this way. So there are a few ways to write this, or -2/5. Um, as you see, this one, we can do each one by itself because we have a sum. If you have a sum of difference, you can do that. This one has a multiple, and this one is the ex. So the antiderivative for a number is just with the x. For this one is x squared over 2, and this one is for x, we add 1, and for ex it's just ex plus c. So we have this 4 is the highest one. It doesn't matter here which way you write it, but just to show some, we'll do 6x. All right. So let's look similarly now, just like consider this following initial value problem. So you have f prime of x, and you need to find the f of x, which is the antiderivative, and we add 1, we divide by it, and we add 1, we divide by it, and we do a c. So 3x cubed minus 4x squared plus c. Then here f of 3 is 49. That means from the previous answer, f of 3 equals 49. And try it. C, C should come up to a 4. Saying that now the state the function f of x by solving the solution of this initial value problem is 3x cubed minus 4x squared plus 4. All right, so now a similar thing with this example. You have a C prime, so it's almost like that similar one we did. This one just an application. So you will need to find the antiderivative by dividing 75x plus C. So the fixed cost, the fixed costs incurred by Carlota here are 4,500 a month. So what does mean the fixed cost? Uh, as we did previously in some models, if you remember that when you do y equal to mx plus b, this is that fixed cost all the time. This one, that's the one that's changing. So similarly here, even if you put 0 for x, c is there, is remaining. So the fixed cost here is going to stand for this. At the beginning, there is a fixed cost of paying the dues, and that cost doesn't go away, and it's 4,500. So 0.03x squared plus 75x plus 4,500 is going to be this requested function. Right? So that this is the total monthly cost. CX, right? That is incurred by this Carlota in manufacturing X guitars per month, and with knowing the fixed cost is 4,500 per month. All right, thank you.